Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about one of the most important chapters of plus 2 second year chemistry CHSE, that is Aldehydes, Ketones and Carboxylic acid. First up, we will discuss in a very detailed and systematic manner about the aldehydes and ketones, and in the next one that we will discuss about the carboxylic acids. Well, first of all, let us try to understand that what do you mean by this aldehydes and ketones. It's very simple to understand, my dear students. The aldehydes and ketones are basically the organic compounds, and these organic compounds are also known as the carbonyl compounds. So the first point that we need to remember, aldehydes and ketones are the organic compounds, and these organic compounds are also referred to as the carbonyl compounds. So why these compounds are referred to as the carbonyl compounds? What is the reason behind it? Yes, since these two compounds possess the carbonyl group, this group is basically called the carbonyl group. So carbonyl group means the group which is formed by the carbon and oxygen. That means the group which consists of the carbon and oxygen, that group is basically called the carbonyl group. Since the aldehydes and ketones contain the carbonyl groups, if you look at the general formula of the aldehydes and ketones, both the formulas contain the carbonyl group. That's why these organic compounds are also known as the carbonyl compounds. So this is the fact that we need to remember from this point. And here, in this carbonyl group, in case of the aldehyde, at least one hydrogen atom is attached to the carbon atom of the carbonyl group. Similarly, in this carbonyl group, in the carbon atom of the carbonyl group, in case of the ketone, the two alkyl groups or aryl groups are attached. In case of the aldehydes, in the carbon atom of the carbonyl group, at least one hydrogen atom is attached. That's why the functional group of aldehyde is HC double bond O. Similarly, in the case of ketone, the two alkyl groups or aryl groups are attached to the carbon atom of the carbonyl group. That's why the functional group of ketone is this RRC double bond O. So this is the functional group of aldehyde, and this is the functional group of ketone. Now, what is the general formula of the aldehyde? Yes, I have written the general formula for you. Have a look on this. The general formula of aldehyde is RCHO. So this is the general formula of aldehyde. So here the CHO is the functional group of the aldehyde. We know that one. But what is this R? Yes, here R is equal to H hydrogen, or R is equal to alkyl group, or the R can also be an aryl group. So if we look at the various examples of this aldehyde related to this general formula, first of all, if we put hydrogen atom in the place of this R, we also have seen here that the R equal to hydrogen or alkyl group or aryl group. So if you will put the hydrogen in the place of this R, then you will get HC double bond O H. That means HCHO. So what is the name of this formula? The name of this formula is the formaldehyde. So formaldehyde is basically the first member of the aldehydes, and this is one of the best examples of the aldehyde group. Similarly, we have other examples. If you will put the first alkyl group, that is the methyl group, that's CHO. If you will put the first alkyl group methyl, that is CH3, then what happens basically? The first alkyl group is CH3. So what is the name of the CH3? CH3 means methyl. So when the methyl group is attached in the place of this R alkyl group, then what happens? Yes, CH3CHO. Here this is the formula is obtained, and what's the name of this one? This is called an acetaldehyde. Similarly, if the phenyl group, if the phenyl group is attached in the place of this R, then here the formula is obtained, that is C6H5CHO, and the name of this compound is benzaldehyde. So these are the various examples of the aldehydes. But how the examples of the aldehydes are written? The examples of aldehydes are written on the basis of the general formula of the aldehyde. So what is the general formula of aldehyde? That is RCHO, where R equal to hydrogen or alkyl group or aryl group. So putting the various compounds in the place of the R, we have written the various examples along with its names. So similarly, what is the general formula of the ketone? Yes, the general formula of the ketone is RRC double bond O, where R is alkyl group or aryl group. So generally the ketone is basically of two types. One is the simple ketone. Another is the mixed ketone. So I want to make you clear that what do you mean by the simple ketone? You know the general formula of ketone, that is RRC double bond O. This is the general formula of the ketone, where R equal to alkyl group or aryl group. Here this is okay, right? But this ketone is further classified into two categories. One is the simple ketone and another is the mixed ketone. So what do you mean by the simple ketone? Yes, if the two alkyl groups are same. So if the same alkyl groups are attached to the carbon atom of the carbonyl group, or if the same aryl groups are attached to the carbon atom of this carbonyl group, then that is what called the simple ketone. But if the alkyl group differ from each other, if the different alkyl groups or the aryl groups are attached in the carbon atom of this carbonyl group, then that ketone is basically called the mixed ketone. So I have written the various examples of the simple ketone. Have a look on this. Here, in the carbon atom of the carbonyl group, this is the carbonyl group, right? In the carbon atom of the carbonyl group, we have two alkyl groups, that is CH3 and CH3. But when the two alkyl groups are attached, that is the methyl groups are attached, only the one type of the alkyl groups are attached, that is only the one alkyl group, that is methyl. So two methyls, that means two methyls are there, no doubt, but alkyl group is same. Here the alkyl group is methyl, here also the alkyl group is methyl. That means if the two same alkyl groups are attached to the carbon atom of the carbonyl atom in case of this ketone, then that ketone is what called the simple ketone. So the acetone is the best example of the simple ketone. Similarly, just have a look on another one. If you look at this one, here we have C2H5, that is ethyl. Here also C2H5 ethyl. That means the alkyl groups are same. In both the cases, the alkyl groups are same. That means the same alkyl groups are attached to the carbon atom of the carbonyl group. That's why, what's the name of this compound? Two alkyl groups are there. That means two ethyl groups are there. So this is called the diethyl ketone. So two ethyl groups are there. That's why diethyl ketone. So this is diethyl and here it is ketone. Similarly, here dimethyl ketone, or we can say acetone as well. So this acetone is a simple ketone. Similarly, the diethyl ketone is also a simple ketone because this ketone consists of the same kind of the alkyl groups, that is same ethyl groups. But here the methyl groups are same. That's why here it is also a simple ketone. But if you look at this compound, here we have one methyl group, another ethyl group. That means the alkyl groups are differ from each other. They are different from each other. So one methyl group is there and one ethyl group is there. No doubt the two alkyl groups are there. Two alkyl groups are attached to the carbon atom of the carbonyl compound. Carbon atom of the carbonyl group. But the two alkyl groups which are attached to the carbon atom of the carbonyl group are different from each other. That means here this is a methyl group and this is ethyl group. Since the two different alkyl groups are attached, therefore this ketone is known as the mixed ketone. And what's the name of this ketone? Here, first of all the ethyl, methyl, and here it is ketone. So ethyl methyl ketone. So these are the various examples of the ketone related to the general formula, that is RRC double bond O. So what have we discussed here? First of all, we could understand that what are the aldehydes and ketones. Aldehyde, if somebody will ask you, because you are studying about the aldehydes and ketones, so you should have a clear understanding of the aldehydes and ketones. So what is the simple answer that you need to give if somebody will ask you what do you mean by aldehydes and ketones? Then the answer is that the aldehydes and ketones are the organic compounds which are also referred to as the carbonyl compounds due to the presence of the carbonyl group. So in case of this aldehyde, at least one hydrogen atom is attached to the carbon atom of the carbonyl group. So the functional group is this one. Similarly, in case of the ketone, alkyl groups are attached. That means the two alkyl groups are attached, in case of the ketone. This is the functional group of the ketone. So the general formula of the aldehyde is RCHO, where R is equal to H, or alkyl group or aryl group. So on the basis of this general formula that we have written the various examples along with its names. Similarly, the general formula of the ketone is RRC double bond O, wherein the two alkyl groups or aryl groups can be attached to the carbon atom of the carbonyl group, right? And on the basis of that, we can classify the ketone into the simple ketone as well as the mixed ketone. So if the same alkyl groups are there, then that is simple ketone. If the different alkyl groups are there, then that is mixed ketone. So we have also discussed the various examples of the simple ketone as well as the mixed ketone along with its names. That means on the basis of this general formula, the various compounds are written and the names of these compounds are also written here. Now we will discuss the nomenclature of the aldehydes and ketones. Well, if we look at the nomenclature of the aldehydes and ketones, first of all, let us try to understand that what do you mean by nomenclature. Nomenclature is very simple, that is, it's nothing but the naming. So now we will try to know the nomenclature of, first of all, the members of aldehydes. Well, we know that the general formula of the aldehyde is RCHO, where R is an alkyl group or aryl group. So based on this general formula, that we will write one by one members, and we will try to name them, and we will discuss the common name as well as the IUPAC name. It's very important to remember, my dear students, because without understanding the names, the common names as well as the IUPAC names, because whenever you're writing any of the chemical reactions, these names are very much essential and important. Before understanding about the methods of preparation of these aldehydes and ketones, you need to understand the names of the members of the aldehydes as well as the ketones. So first up, we will discuss the members of the aldehydes. So look at here, the general formula of the aldehyde is RCHO. So if I will put the hydrogen atom in the place of this R, then what the formula is obtained? Here the formula will be obtained, that is HCHO, right? I have written it in the short form that if you will apply the hydrogen atom in the place of this R, then you will get HCHO. That means HCHO. So this is what basically called the aldehyde. CHO means this is the functional group of the aldehyde. So since here, look at here, since the hydrogen atom is attached here, that's why the common name in this common name, what generally obtains in the common name, if hydrogen atom is there, then that is called the form, and CHO is there, and this is aldehyde. Now what the name has been obtained here? Yes, here the name is formaldehyde. Yes, and here instead of the name, let us write we will write the structure. If you look at the structure, if you apply the hydrogen here, then the structure comes like this. That means this is hydrogen, no doubt, and this is aldehyde. While giving the common name to this compound, this is aldehyde, no doubt. So aldehyde, you have put the aldehyde, and if hydrogen atom is there, in case of the common name, you will add one word, that is form. Now the form plus aldehyde, that is formaldehyde. So HCHO means what is the name of this? What is the common name of this HCHO? What is the common name of this compound? That is formaldehyde. Similarly, what is the IUPAC name? Iupac Name, International Union of the Pure and Applied Chemistry, because some of the students may have the doubt of the full form of the IUPAC, International Union of Pure and Applied Chemistry. The IUPAC name, in order to identify or in order to recognize the IUPAC names of the different compounds, it's very easy to understand, my dear students. To recognize the IUPAC names, we need to remember, we need to calculate the number of carbon atoms. That means how many carbon atoms are there. That's what it is here, it is based on. And we also should remember about the suffix of the compound. In case of the aldehyde, you need to remember the suffix, that is Al. So Al is the suffix which is used in all the members in case of the aldehyde. So what is the suffix of aldehyde means you have to say that is Al. So now we will try to give the name of this, the formaldehyde, that is the IUPAC name. Well, IUPAC name is that here one carbon is there. So how many carbon atoms are there? In order to give the IUPAC name, that I also say that one carbon atom is there. So one carbon atom means that is methane, right? This one. If one carbon atom is there, then that is methane. But here what happens, the E will be replaced. The E will be replaced as Al. That means the E will be replaced by Al. So if E will be, because Al is the suffix of aldehyde, if E is replaced by Al, then what the name is obtained? That is methanol. Yes. So the methanol, the methane, why the methane? First of all, I have written there because one carbon atom is there. Since one carbon atom is there, that's why the carbon, that is methane. And what is the suffix of, what is the suffix of this compound? Here the suffix of aldehyde is Al. That's why the E is replaced by the Al. And finally we got the name, that is methanol. So methanol is the first member of the aldehyde. So what is the first member of the aldehyde? That is methanol. What is the formula? HCHO, or according to the structure wise we can write like this way. And what is the common name of the first member of the aldehyde? That is formaldehyde. And what is the IUPAC name? That is methanol. Similarly, we will move on to the second one. Well, if you see, if you will put the first alkyl group, that is CH3 methyl, in the place of this R, what is obtained here? Yes, you will write CH3, C double bond O, CHO. That's right. So in the way we can write here CH3, CHO. So look at here. Here I have placed CH3 in the place of this R, and remaining CHO is there. CHO, this is aldehyde, While writing the common name, that you need to write the aldehyde. Aldehyde. Yes. But here, if hydrogen is there, means how we just put the form. Similarly, if CH3 is there, you just remember it as acid. Yes. Now what is the name of this compound? Acetaldehyde. So CH3, you remember it as acid, and CHO, this is as aldehyde. So acetaldehyde. So acid plus aldehyde equal to acetaldehyde. And that's the formula of this one, and the structure along with the common name. Now, how to, IUPAC name means, first of all, you need to identify how many carbon atoms are there. How many carbon atoms are there? 1 and 2. 2 carbon atoms are there. Since 2 carbon atoms are there, we'll write ethane. And what is the suffix of this aldehyde? The suffix of this aldehyde is Al. So this E will be replaced and Al is attached here. That means you will have to write, that is ethanol. So what is the second member of the aldehyde? Yes, the second member of the aldehyde is ethanol. I hope you understand it very clearly, right? On the basis of this general formula that I am writing one by one, the one by one member, first of all, I have placed the hydrogen atom in the place of this R, and I have written the structure, common name along with IUPAC name. Similarly, I have put the first alkyl group, that is the methyl, in the place of this R, and the structure is obtained like this. I have written the common name along with the IUPAC name. So the second member of the aldehyde group is ethanol. So the ethanol, what is the formula for ethanol? CH3 CHO. Or what is the formula for acetaldehyde? CH3 CHO. So ethanol is the acetaldehyde, but acetaldehyde is the common name and ethanol is the IUPAC name. That's it. Now move on to the third member. Yes, if you will put the next member of the alkyl group in the place of this R, then what is obtained? If you will put the next member of the alkyl group, then you will write CH3 CH2 C double bond OH. That means CH3 CH2 CHO. Yeah. So look at here, the next member of the first member of the alkyl group here, it is methyl. The next member of the alkyl group is ethyl. So we are generally writing ethyl is C2H5. So here I have just stretched here, that is CH3 CH2. CH3 CH2 means this is C2H5 or not? Yeah, this is C2H5. And according to the general formula that I have placed here, the next member of the alkyl group, and I have written the formula in a very simple manner. So now I have to write the common name as well as the IUPAC name. What I have said, if CHO is there, then it's better you write the aldehyde. Yes, if CHO is there, means you no need to consider anything. In case of this common name, you just write the aldehyde. And here the CH3 CH2, for the next member that you need to write propione. Yes, now what is the name of this compound? Propionaldehyde. So CHO is there, means you have written aldehyde, and here CH3 CH2, for this CH3 CH2 that you have written propione. That means what is the name of this compound? Propionaldehyde. So the common name of this compound is propionaldehyde. Now we will discuss the IUPAC name. IUPAC name is very easy to identify, right? Because you see, first of all, you need to identify two things here. The first thing is that number of carbon atoms. How many carbon atoms are there? 1, 2, 3. 3 carbon atoms are there. So if 3 carbon atoms are there, means you know that it is a propane, right? That is propane. And in propane, the E will be replaced by the suffix of the aldehyde, that is Al. So what will happen here? You will get propanal. Yes, because the E is replaced by the Al, and finally the propanal is obtained. So here the propanal is the IUPAC name of this compound. Similarly, the propionaldehyde is the common name of this compound, and the propionaldehyde and propanal, they are not different from each other, but this is just common name, and that's just the IUPAC name. And the formula of both this names both, and the formula of propionaldehyde as well as the propanals are generally same. Now we will move on to the next member. Well, if you will place the next member of the alkyl group here in place of this R, then what generally happens? Yes, you will get CH3, CS2, CS2, CHO. Okay, and in the simple manner that you can write CH3, CH2, CH2, CHO. Yes, in the simple way that you can write CH3, CH2, CH2, CHO. But according to the structure wise, I have written CH3, CH2, CH2, CHO. And what the structure that I am writing here, this is a condensed structure. But this is not an elaborate or this is not the extended structure. The structure what I am doing here, this is a condensed structure. And the condensed structure, I think this condensed structure is easy for you to understand. In the place of this R, that you are putting the various alkyl groups. So here in the place of this R, that I have put the alkyl group, that is CH3, CH2, CH2. Here the CHO is there. So in the place of this CHO, then you can write aldehyde, right? And CH3, CH2, CH2. And here in this place that you can write butane. Butane. Now what is the name of this compound? Butyraldehyde. So butyraldehyde is the the common name of this compound. Similarly, IUPAC name, it's very easy to identify. You tell me what is the IUPAC name of this compound. Tell me how many carbon atoms are there? 1, 2, 3, 4. So 4 carbon atoms are there. 4 carbon atoms are there, means no doubt you can say that it is butane. And what is the suffix of this aldehyde? Yes, the suffix of this aldehyde is Al. So, the Al, the E will be replaced. In case of the butane, the last E will be replaced by, this Al. And finally, it obtains. And finally, we get Al, that is butanal. B-U-T-A-N-A-L, butanal. So, butanal is the 4th member of the aldehyde. So in this way, we can write the various members of the aldehydes, and we can give the names of the common name as well as the IUPAC name. We can easily identify the common name as well as the IUPAC name. That's all about, the members of the aldehydes. I think you understood, what are the different members of the aldehydes. Here, the first member of the aldehyde is formaldehyde, or in case of the IUPAC name, that we can say methanol. And we have various members of these aldehydes. But I think these, the first 4 members are very much important for you to, write in the various reactions. I hope you understood both the common names, IUPAC names, the structure and formula, based on the general formula of the aldehydes and the members of the aldehydes. Now we will discuss, the members of the ketones. Well, if we look at the members of ketones, first of all we need to look at the general formula of the ketone. So what is the general formula of ketone? RRC double bond O. So here the ketone consists of two alkyl groups, or we can write the aryl groups as well. If you write the two alkyl groups, that is the CH3, here the CH3, yes, so I have just placed here the two methyl groups in the place of this R, because the two alkyl groups are there. So in the place of these two alkyl groups I have placed here CH3, CH3. So what is the, if I will write here, I also can write like this CH3 or CH3. So this also can be written like that, or I can simply write CH3CO CH3. So this is the simple way of writing the formula, and the structure also can be extended in the various ways. What is the common name of this one? Yes, the common name is that, first of all, here we need to remember this is basically CO is there. CO is there means we can say that ketone, right? But here the CH3, the two methyl groups are there, and the two methyl groups are attached to the carbon atom of the carbonyl group. In that case you need to write the common name, that is acetone. So what is the name of this compound, that is CH3CO CH3, that is acetone. So if acetone comes means immediately that you need to set right, you need to get your mind that is CH3 C double bond O. So this is the formula for the acetone. And in case of the Iupac name, means generally we were considering the two things. First of all, the number of carbon atoms. Secondly, the suffix of this ketone. So what is the suffix of the ketone? Here the suffix of the ketone is ONE. So ONE is the suffix of this ketone. So if you will count the number of carbon atoms, that is 1, 2, 3, yes, 3 carbon atoms are there. So if 3 carbon atoms are there means you will write propane, right? And at the last the E will be replaced. I will show you here, that is PROPANE. 3 carbon atoms are there. Since 3 carbon atoms are there, so I have written here propane. And what happens here, the E will be replaced by the suffix of this ketone, that is ONE. Then what the name is obtained here, tell me? That is propanone. So propanone is the first member of the ketone. I hope it's very clear for you. Now we'll move on to the method number 2. And this is a simple ketone as well. Why? Because here the two alkyl groups which I have written here, both the alkyl groups are same, that is methyl groups. I can just change the alkyl group. So if you will put here just what happened, if you will put here CH3 and if you will put here C2H5, yes, if you will put here C2H5 and if you will put here CH3, of course two alkyl groups are there, no doubt. But here one alkyl group is methyl and another is ethyl. That means the alkyl groups are different from each other. That means this is a mixed ketone. In this case, how the name will be given, alphabetical order. First of all, this is ethyl, right? So we need to write that ethyl, then methyl, ethyl, methyl, and this is ketone. So ethyl, methyl, ketone, right? Let me tell you once more, right? Since the two alkyl groups are there, but the two alkyl groups are different from each other, and that's why this is a mixed ketone. And here the methyl group is there and here the ethyl group is there. And in that case, how the common name, that means how the name will be given in the common name, that is the first one ethyl and the next that is methyl. So ethyl, methyl, ketone. So this is the common name of this compound. Similarly, I can write the Iupac name. Iupac name is very simple. First of all, you will write the number of carbon atoms. On the basis of the number of carbon atoms, you can say whether it is propane or butane or pentane or whatever it may be. And then after you will find out the suffix of the member, right? Yes. So how many carbon atoms are there? 1, 2, 3, 4. So 4 carbon atoms are there. 4 carbon atoms are there means I can write butane, right? So at last the E will be, the E of the butane will be replaced by the suffix of the ketone. The suffix of the ketone is ONE. So the E of the butane will be replaced by the suffix of the ketone, that is butanone. Yes. In butane, if E is replaced, right? If E is replaced by ONE, then what the name is obtained here? That is butanone. So this is one of the another members of the ketone. Similarly, I can put in case of this R, I can put both C2H5 and C2H5 I also can write like this. Look at here. Here the two alkyl groups are same, but that means the two ethyl groups, I have written here the two ethyl groups, that is C2H5, C2H5, say double bond O, that's what. So here the two alkyl groups, that is ethyl groups are there, so I can write the common name, that is diethyl, because two ethyl groups are there, so diethyl ketone, that I can write here, diethyl ketone. Yes. So what is the Iupac name? Iupac name is very simple to understand. Number of carbon atoms to be counted here. How many carbon atoms are there? Here 2, 2, 4, and here it is 5. So 5 carbon atoms are there. So 5 carbon atoms are there means obviously you can say that it is a pentane. And at last the E will be replaced of, the pentane. E will be replaced by the suffix ONE. So what the name is obtained here? That is pentanone. Pentanone. So these are the various members of the ketone. I have just written, the 3 members of, the ketone. There are many of the members of the ketone. But to make you very clear, to make you understand, these members have been written for you. And here, mostly in the chemical reactions, the acetone is used a lot. So you need to remember the formula for acetone, that is CH3CO CH3. And the Iupac name for that is propanone. Since mostly, among these 3 members, out of any of the acetone or ethyl methyl ketone, I mean to say that often these 3 members are repeated again and again in the methods while doing the methods of preparation, as also while taking it into the chemical reactions. Since these are repeated again, so that you need to remember the names of these compounds, that is CH3CO means acetone, and here it is like that ethyl methyl ketone and diethyl ketone. And I think these 3 things, these 3 members will help you a lot to understand further, to remember the names of the ketones. Well, this is all about the members of the ketones based on the general formula. Now we will discuss, because you see the aldehydes and ketones. The aldehydes and ketones, they show the isomerism. So let me give you a brief understanding on the term isomerism. What is isomerism? What are the different types of isomerism? And how the aldehydes and ketones show the isomerism, that we will discuss now. Well, what is this isomerism? Let me give you a brief understanding on this. Well, isomerism is basically a term. So if you look at this term, this is derived from the Greek words, 2 Greek words, that is iso means equal and meros means parts. Before understanding that the isomerism, that the aldehydes and ketones, how the aldehydes and ketones can show the isomerism, first of all we need to understand that the some things about the isomerism, right? So iso means equal and meros means parts, or equal parts or the same parts. So the same parts is basically called the isomers. And isomerism is basically a phenomenon. It is a phenomenon in which the more than one compounds are identical in the chemical formula. They have identical chemical formula but differ in their properties and the arrangement of atoms in the molecules. So once again I am telling you the definition. Isomerism is a phenomenon in which more than one compounds have identical chemical formula but differ in the properties and arrangements of the atoms in the molecules. Well, this term was first coined by a Sweden chemist, that is Jacob Berzelius. So Jacob Berzelius is a Sweden chemist, and this term was first coined by that chemist in the year 1830. So this is also one of the most important point that we need to remember from here, my dear students. So what is this isomerism? Isomerism is a phenomenon in which more than one compounds having the chemical formula same. That means having the identical chemical formula but differ in the properties and arrangement of the atoms in the molecules. And this term was first coined by the Jacob Berzelius in the year 1830. And if we will split the substance, if we will split the term, that is isomerism, then iso means equal and meros means parts. So equal parts or the same parts, then we can say that is isomers. And the compounds which exhibit the isomerism, those compounds are called the isomers. Now this is what we need to remember from here. Well, let me give you a brief chart to remember this isomerism. that first of all you could understood that what do you mean by isomerism. We will discuss much more examples to make you very much clear about the isomerism. But before that, let me give you a brief chart on the isomerism. Basically, have a look on this chart. This isomerism is primarily divided into two types. One is the structural isomerism and another is the stereoisomerism. This structural isomerism is further classified into the chain isomerism and position isomerism, functional isomerism, metamorism and tautomerism, and all these isomerisms can be shown by both the aldehydes as well as the ketones. That means the aldehydes and ketones can show the isomerism. The aldehydes and ketones can show the chain isomerism. The aldehydes and ketones can show the position isomerism, can show the functional isomerism, metamorism, tautomerism. But how these aldehydes and ketones can show these types of the isomerisms, that we will discuss. And here the stereoisomerism is divided into two types. One is the geometrical isomerism. The geometrical isomerism, the isomers which differ in the special arrangement about a double bond. So the isomers which differ in the special arrangement about a double bond is known as the geometrical isomers, and the phenomenon is known as the geometrical isomerism. So here the optical is also one of the subtype of the stereoisomerism. So what is this optical isomerism? The isomers which differ in the arrangement of the atoms in the 3D space, and the phenomenon is known as the optical isomerism. So isomerism is basically a phenomenon, but the isomers, I have just said here, the compounds which exhibit the isomerism, that is called isomers. That are isomers which shows the isomers are obtained, but the phenomenon of that is what basically called the isomerism. That means here optical isomerism, the isomers differ in the arrangement of the atoms in the 3D space. There are many more substances, there are many isomers which differ in the arrangement of the atoms in the 3D space. That is called the optical isomers, and the phenomenon is called optical isomerism. I hope you very clear about the term isomerism, that how the isomerism, how it is divide. The name is obtained from the Greek words, that is iso means equal and meros means parts, and who the person gave this name, and along with I have given you a very brief chart. I hope that if you will take a screenshot of this, it's better that you understand it in a very detailed and systematic manner. So isomerism, two types, that is structural and stereo. These are the subtypes of structural, and these are the various types of a stereoisomerism. Now we will discuss one by one. That is, the structural isomerism, chain isomerism, position isomerism, functional isomerism, metamorism and tautomerism, along with its examples. But we will take the examples of the aldehydes and ketones. But I have said that, because aldehydes and ketones can show the isomerism. So aldehydes can show the chain isomerism. First, so we will discuss what is chain isomerism and how the aldehydes and ketones can show the chain isomerism, and we also discuss how the aldehydes and ketones can show the position, functional, metamorism, tautomerism, everything. So let us discuss about the structural isomerism. So what is the structural isomers? So structural isomerism is basically a phenomenon. And this structural isomerism is also known as the constitutional isomerism. This is also one of the most relevant points that we need to remember here. So what is the structural isomerism? It is a phenomenon in which the functional groups and the atoms of these isomers are linked different ways, and these are assigned the different IUPAC names because these may or may not contain the same functional groups. Since these may or may not contain the same functional groups, these may assign the different IUPAC names. So the functional groups and the atoms of these isomers are linked in the different ways in case of the structural isomers, and the phenomenon structural isomerism. And the structural isomerism is also known as the constitutional isomerism. Well, the structural isomerism is also divided into various types. The first one we have, that is the chain isomerism. So what is this chain isomerism? Let me highlight some of the points of the chain isomerism. The chain isomerism, also known as the skeletal isomerism. This is the point that you need to remember here, my dear students. And the second point we have, the components of these isomers display differently branched structure. That means the branched structure will be different in the components of these isomers. That means in the phenomenon of here in this chain isomerism. And the point 3 we have, they differ in the branching of the carbon atoms. Let us look at some of the examples of the chain isomerism. Here we will take the example of the aldehydes, aldehydes, because we can easily identify whether the aldehyde can show the chain isomerism or not. The chain isomerism is very simple to understand, my dear students. The chemical formula will be same. The compound having the same chemical formula but differ in their chain, structure. That is what the chain isomerism. So look at here the example. Here we have CH3, CH2, CH2. So this is one of the examples of the aldehyde. This is one of the example of the aldehyde. We also had discussed the name of this one in the nomenclature. So what is the name of this compound? Butanol, because 1, 2, 3, 4 carbon atoms are there, and this is an aldehyde, right? So the suffix Al is used. So butanol. If you look at here, CH3, CH, CHO, here one branched one. That means the methyl group is attached in a branch as a substituent. So if you look at here, the name of this one, this is 2. That means 1 or 1, 2, 3. 1, 2, 3. In the position of this 2, the branch, that is the substituent CH3 is attached. That means 2 methyl and 1, 2, 3, that is propane. So 2 methyl propanol. Because why this L propanol is added? Because here it is this is an aldehyde group. So if you observe it very carefully, you both are having the same chemical formula. That is CH3. How many C is there? Here the 4 C is there. Similarly, here the 4 carbon atoms are there. How many hydrogen atoms are there? Here 3, and this is 2, 5, 6, 7 and 8. Yeah, similarly here it is 3, 3, 6, 7 and 8. So that means 8 hydrogen atoms are there, and 8 hydrogen atoms are there in here in this case, as well as 4 carbon atoms and 4 carbon atoms and 1 oxygen atoms are there. That means the chemical formula are same here, but what is different? They are differ in their chain structure. Since they are differ in their chain structure, that's why this is called the chain isomerism. So what is the chain isomerism basically refer to? The compounds having the same chemical formula but differ in their chain, differ in their chain length, are called the chain isomers, and the phenomenon is called the chain isomerism. So we have taken the example of we have written the properties of the chain isomerism along with the examples that I have mentioned here, the example of the aldehydes, because how the aldehyde can show the chain isomerism, that's what I just wanted to convey through. And next we will discuss about the next subtype of the structural isomerism, that is we will discuss about the position isomerism. So what is this position isomerism? I have written here the 2 properties of the position isomerism. The positions of the functional groups or the substituted atoms are different in the position isomers. Similarly, the isomers in which the attachment of the functional groups will be different to the different carbon atoms. That means the functional group, the position of the functional group will be different in the carbon atoms of these compounds, but the chemical formula will be same. So if position isomerism means what we can say that the compounds are having the same chemical formula, identical chemical formula, but what is the different? The different is that the position of the functional group will be changed. So if you observe it very carefully, that I have written the example of a ketone, that here CH3 single bond, CH2 single bond, CH2 single bond, C double bond was CH2, CH2. Here this is 1 and this is 2 at the position number 2. Here the functional group is attached, that is pentane 2-ONe. Similarly, if you look at here 1, 2, 3, that means here the position number 3, the functional group is attached. That means the position of the functional group is different. That's why this is called the position isomer, and the phenomenon is called the position isomerism. So what is the position isomerism? The compounds having the same molecular formula, same identical chemical formula, but differ in the position, that is the position of the functional groups or the substituted atoms. So this is what we have written the examples of the ketone. Of course both are having the same chemical formula, but what is different between these two? The position of the functional group is different. What is the functional group? Ketone is the functional group, right? But here the ketone is in second position, here the ketone is in third position. It doesn't mean that the chemical formulas are different. The chemical formulas are same, but the position of these functional groups which is attached to these compounds are different. That is what basically called the position isomer, and the phenomenon is called the position isomerism. I hope it is very clear to you. Now we will discuss the functional isomerism. So what is functional isomerism? You know, the phenomenon in which the compounds having the same chemical formula but different functional groups. So in case of this functional isomerism, what we need to observe here, the same chemical formula will be there, but the functional group will be different, and that compound is that compound is called the functional isomer, and the phenomenon is called the functional isomerism. And this isomerism, this functional isomerism, is also known as functional group isomerism. This is we need to remember. So what is functional isomerism means? What do we say? That the functional isomerism, the compounds in which, or the compounds having the same chemical formula but different functional groups are known as the functional isomers, and the phenomenon is known as the functional isomerism. Let me give you the examples of this one. Here, look at here. Here I have written the example of aldehyde. Here I have written the example of the ketone, because here the aldehyde functional group is there and the ketone functional group is there. Look at here aldehyde, since the functional group is aldehyde, here the functional group is ketone. That means the functional group are not same to each other, they are different from each other. So that's what I have said here. In case of this functional isomerism, the same chemical formula will be there. Here the chemical formula will be same. Look at here the 3 carbon atoms are there, and for 3, 4, 5, 6, that means C3H6O. Here the chemical formula of this compound is C3H6O. Similarly here also three carbon atoms are there, and 6 hydrogen atoms are there, and 1 oxygen atom is there, C3H6O. That means the chemical formula of both these compounds are same, but what is different here? Here the functional groups are different. So that is what basically called the functional isomerism. So functional isomerism, the compound having the same chemical formula or identical chemical formula but different functional groups are known as the functional isomers, and the phenomenon is called the functional isomerism. So that's all about the functional isomerism. Now we will discuss another type of the structural isomerism, that is metamorism. So what is metamorism? Let us look at some of the properties of metamorism. This type of isomerism, arises due to the presence of different alkyl chains. Because different alkyl chains are there, means definitely this type of the metamerism generally arises. So metamerism arises due to the presence of different alkyl chains on each side of the functional group. Look at here. This is here a functional group, that is ketone is there. Here in this ketone we have alkyl groups are there, that is ethyl groups are attached to both the sides of this the ketone, both the sides of this ketone functional group. Similarly, if you look at here methyl group is attached, here the propyl group is attached, but here it is also something different. So I have written the 3 the compounds 1, 2, 3. If you look at here 1, this is pentane 3-ONE, because in the position 3 the functional group is attached. That's why this is pentane 3-ONE. Here the position 2, that's why the pentane 2-ONE. But here it is completely different. Here 1, 2, 3, 4, in second position functional group is there, and third position one substituent is also there, that is methyl group. So methyl butanone, here it is named as. That means this is basically a metamorism. And why this arises? Due to the presence of different alkyl chains. This alkyl chain is different to this this one, this alkyl chain is different to this one, right? And it is a rare isomerism, and generally limited to the molecule that contain a divalent atom such as sulfur or oxygen, which is surrounding to the alkyl group. So this is all about the metamorism, and how the aldehydes how the ketones this is what the examples of the ketones generally I have shown for you about the metamorism. So this is the entire things about the metamorism. And now we will discuss the tautomerism. So what is this tautomerism basically refer to? A tautomer of a compound refers to the isomer of that compound which only differs in the position of the protons as well as the electrons. So this is one of the relevant points that you need to remember. And here one more point is that here we have they exist together in the equilibrium state. So let us look at here the example so that you can understand it very clearly. I have written here the acetaldehyde, that is CH3CHO, that is acetaldehyde. The acetaldehyde in the equilibrium form, that we also can write that CH2 double bond C bond and H, and here it is OH. So this is the enolic form. This is called the enolic form. That means here the equilibrium state is obtained. Similarly, I have written here the acetone CH3COCH3, that is also an equilibrium sign along with the enol, that is CH3 See, almost the chemical formulas are same here, but they exist, typically these exist together in the equilibrium state. What is that? That is what basically called the tautomerism. This phenomenon is called the tautomerism. So that's all about the entire things. We have discussed about the structural isomerism, we have discussed about the chain isomerism and how the aldehydes and ketones can show that one, position isomerism, functional isomerism, metamorism, tautomerism. In this way the aldehydes and ketones can show the isomerism. In order to make you understand very clearly that how the aldehydes and ketones can show the isomerism, that I have given you such a detailed analysis of this one. Anyhow, this is enough for today's session, and in the next video lecture that we will discuss the structure of the carbonyl group, as well as the methods of preparation of the aldehydes as well as the ketones. And if you would like to watch the next part of this video lecture, that I would request you to press the bell icon over here to get the latest notification. Thank you very much for watching.